Welcome to Section 2, Question 3 of the 2010 Mathematical Methods Exam 2. In this video, we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And finally, as we progress through this question, you will notice that there are colour-coded boxes to indicate how likely the CAS calculator is to be used efficiently when answering each subpart of the question. So for question 3, the introductory information says, an ancient civilization buried its kings and queens in tombs in the shape of a square-based pyramid. And for this particular example, it's labelled as W, A, B, C, D. So that's each of the vertices on that pyramid. The kings and queens were buried in a pyramid with WA equaling WB equaling WC equaling WD, all being 10 metres. So for example, WA is this length here, and that would be 10 metres. Each of the isosceles triangular faces is congruent to each of the other triangular faces, so that just means all 4 of the triangles that form the faces of this pyramid are exactly the same shape and size. And we know the base angle for each of these triangles is x, and that's shown down here on the diagram. And x is between pi on 4 and pi on 2, both not included, for all of these pyramids. Next up, we're told that z is the midpoint of AB, so that means that this length and this length must be equal when we move through this question. And part AI asks us to find the length AB in terms of x. So the length AB is just along here, and in the second diagram, AB is this length. And we can see that it has something to do with a right-angled triangle in that left diagram. So if I just draw out part of the left diagram, we'd have this slant length, which goes from W to A, and that is going to have a length of 10, because that's the information that was given up here. And then we're going to go from W to Z along this length. So this vertex down here would be Z. And if I just color code this is half of the green length. So that's from A to Z. And we know that this is a right angle and that this is the angle X. So we have a right angled triangle. So we know that SOHCAHTOA will apply. And in relation to this X, AZ is going to be the adjacent length. So I'm actually going to start with cosine of theta is equal to A divided by H. So therefore, for this diagram, we'd have cosine of the angle X is equal to the adjacent, which is AZ, divided by the hypotenuse's length of 10. So therefore, AZ, if we got that by itself, would just be 10 times cos of X. Now, we don't want AZ, we want AB. So we know that AB is equal to 2 times the length AZ. So therefore, AB is going to equal 20 cos of X. So that's the answer for part AI of this question. If we then want to find WZ, that would be the length here, if I just do that in pink. And we would see that that is opposite the angle X, so it's going to be sine that relates these lengths and angles. So we're going to say that sine of X is equal to the opposite, which is WZ, divided by the hypotenuse length, which is still 10. So therefore, we have that WZ is equal to 10 sine of X. So that would be the answer to part 2 of part A. So from the examiner's report, we can see that 52% of students got that mark correct for part AI, and that 54% of students got part AII correct. And for both of those, some other equivalent forms were also acceptable for the responses. For part B, it asks us to show that the total surface area, including the base, of the pyramid WABCD is given by S equals 400, then multiplied in brackets, cos squared of x plus cos of x sine of x. So the word show, or in fact show that in a maths exam, means that we've got to find that answer by almost pretending like we don't know what it is. So we've got to start at the very start of this question and show that that result falls out. So what we do know is that S is going to equal the area of the square base, so in green I've just drawn that out on the diagram, that's the area of the square, and then we'd add on to that 4 triangular faces which are all congruent, so the same shape, the same size, so we can just do 4 times the area of one of the triangles. So therefore S is going to equal, and the area of the square is just AB squared, and from part A we knew that AB was 20 cos of x, so we can just have 20 cos of x squared, and just be really careful with the placement of brackets to make sure you're squaring all of that. And then we still need to add on to that 4 times the area of the triangle, which is 4 times 1/2 times the base length, which we knew was AB, so that's 20 cos of x. And then we still need to multiply that by the height of that triangle, which is WZ, which we found before to be 10 sine of x. So we're going to multiply that by 10 sine of x. Therefore, S is going to equal, and here we'd have 20 cos of x squared. We need to square the 20 to give 400, and square the cos x to give cos squared x. So just make sure the power 2 actually goes between the cos and the x. And then for our next part that we're adding on, we're going to have 4 times 1/2 times 20 times 10. So keeping track of all of that, 4 times 1/2 is 2, times 20 is 40, times 10 is 400. So we're going to have plus 400. And then we've still got multiplied by cos x sine x. So that's 400 cos x sine x. So then we're nearly at our desired answer that we're asked to show. And the difference between where we're at the moment and the actual answer is just factoring out that 400. So therefore S is equal to 400, and then in brackets we'd have cos squared of x plus cos of x sine of x. And that's the answer that we needed to show. So we're finished with part B of this question. So from the examiner's report, we can see that the show that question required adequate working for the marks to be awarded. And we can see that 42% of students got full marks for that, with 47% of students actually receiving no marks for that question. Often there was poor use of brackets, and the placement of the squared sign was often seen in the wrong position. So just make sure that as you're going through a question like this, you use brackets when they're needed, and don't confuse cos of x squared with cos squared of x. So make sure that power goes between the cos and the x. For part C, we're asked to find WY, which is the height of the pyramid, in terms of x. So WY is this line here, which I've just drawn out in blue. And to find that, we're going to actually need to work with a couple of right-angled triangles. So the first one that I want to consider is actually the base. So if I just do that in green, we can redraw that square over here. So just for a bit of context, this would be A, this would be B, this would be C, and this would be D. So this is the square base. And the length from A to C, which goes through Y, I'm just going to do in orange, so that would be this length here. And I'll just include that right angle in there. And what we know is that this is a square, so that this length and this length must be the same. And the whole way along, we've known that A to B is 20 cos of x. So therefore, we know that the length AC, which I've just done in orange, its length squared is going to equal the AB squared plus BC squared, which is 20 cos of x squared plus the same thing, so another 20 cos of x squared. And again, just make sure that there's brackets in the right spaces around those. And now this is something that we could use our calculator to help find quite quickly. So what we're going to do is we're going to go into the main menu. And now one way we could do this is we could just say that AC is equal to Y. So we'd have something like Y squared is equal to. And then we want to type in brackets, 20, and then we need cosine of x, and then that's close bracket squared, plus, and then it's actually the same expression again. So that's what Y is going to equal. And then we could highlight and solve that for Y. So we can go interactive equation equality solve for the variable Y, and that will get AC by itself. And because it's a length, we'd want the positive case just here. The other way you could do that, I'll just quickly show you, is you could understand that if you have AC squared equals, then for a length, we just want the square root of the right-hand side. So I'll just drag that down and put that inside the square root sign. Hitting execute will give us 20 root 2. And then you'll come across these straight up and down lines, and some of you may know that they stand for an absolute value. But what we can interpret this as is just 20 root 2 cos of x is what AC is equal to. So therefore, from the calculator, we found that AC by itself is equal to, and ignoring the modulus or absolute value straight up and down lines that the calculator gave, or even just referring to the first way that I showed on the calculator, we knew that AC was just equal to 20 root 2 cos of x. However, we don't need all of AC, we actually just need to know A to Y to do this question. So if we put Y in this diagram, Y was going to be right in the middle, so this is Y just here. And A to Y, if I just keep doing that in purple, that's going to form part of the right angled triangle we need to find WY. So A to Y is just half of A to C. So therefore we can say that A to Y is going to equal 10 root 2 cos of x. Now that we have AY and we have YW in blue, and we can use this slant length just along here, which is 10, we can draw out another right angled triangle that will allow us to find WY. So starting with that hypotenuse length of 10, and we know that A to Y in purple would have sat along here, and in blue, if we connect that all up, that will be WY. So I'll just go and label everything now. This is going to be W, this is A, and this is Y, and that's a right angled triangle as well. We can now use this triangle to find WY. So that purple length was 10 root 2 cos of x, just for our reference on the diagram. So therefore, WY all squared is going to equal, and just be careful of applying Pythagoras' theorem here, it's actually going to be the hypotenuse squared, which is the 10 squared, minus away our other side length squared, which is the 10 root 2 cos of x, and that's got to be squared. So we have another equation that we can use our calculator to help simplify and solve. So this time it was WY squared, and I'm actually going to show you that second method that I just showed previously, where we just take the square root of the right hand side to get WY by itself. So we're going to have the square root of, and then it's going to be 10 to the power of 2, and then we're going to have minus, still under the square root sign, in another set of brackets, the 20 root 2 cos of x halved, so that's just going to be 10 root 2 cos of x, and then we need to square that as well. And then hitting execute will give us this output. So therefore, from the calculator, we found that WY, which is what the question asked for, is going to be equal to 10 times the square root of, and then under the square root sign, it was minus 2 cos squared of x plus 1, which I'm just going to rearrange slightly to be 1 minus 2 cos squared of x. So that is the answer to part C of this question. From the examiner's report, we can see that these questions are getting more challenging as we progress, with only 26% of students getting full marks for that question, and almost 70% of students getting no marks for the question. The examiner's report goes on to say that equivalent forms of the answer were acceptable, and that again there was some poor algebra and use of brackets in this question. Some of the examples of poor notation included root 200 cos of x turning into 200 cos of x with the squared appearing on the x, rather than it being written as 200 cos squared of x, which is the correct way that this would become that. And the same thing here, poor understanding of how surds worked meant that students tried to simplify the square root of 100 sine squared of x minus 100 cos squared of x as just being 10 sine of x minus 10 cos of x, which is certainly not true. For part D, we're told that the volume of any pyramid is given by the formula that the volume is equal to 1/3 times the area of the base times the vertical height. So the area of the base was a square base pyramid, so that was introduced in the introductory information right the way at the start of the question. So if I just do that in green again, that's this square base just here. And each of those lengths are equal, and we knew that the length of that was 20 cos of x. We also found that the vertical height, which was wy, was equal to 10 times the square root of 1 subtract 2 cos squared of x. So we can now use all of that information to show that the volume T of the pyramid is given by this expression. So T is going to equal 1/3 times, and the area of the base is going to be 20 cos of x squared. And then we're going to multiply that by the height of the pyramid, which was 10 square root of 1 minus 2 cos squared of x. So therefore, T, which is the volume, is going to equal 1/3 times, and then we need to square 20 cos of x. So 20 times 20 will actually give 400, and then cos of x being squared is the same as cos squared of x written like that. And then we're going to still have this multiplied by 10 times the square root of 1 minus 2 cos squared of x. So therefore, T is going to equal, and now all of these numbers, the 1/3, the 400, and the 10, which are multiplied together, is just going to give 4,000 over 3, if I just combine those. And then the cos squared of x, I'm actually going to put under a square root sign as being cos to the power of 4 of x. And that's just because we can see that we only want one surd at the end of the day. So by creating this into a surd or under a square root sign, we can still multiply it by the next surd, which is going to still be the 1 minus 2 cos squared of x. And that will lead to our final line, which will show the result that was required. So T is going to equal 4,000 over 3. And then it's going to be 1 square root, and we can just think of this a little bit like how we expand brackets. We're just going to multiply cos to the power of 4 of x times the 1 minus 2 cos squared of x. So multiplying it by the 1 first will just give cos to the power of 4 of x, and then multiplying it by minus 2 cos squared of x will get minus 2 cos, and this will now be to the power of 6 of x. So that is the final result that we were asked to show. From the examiner's report, we can see that 22% of students got this question correct, and that this was a show that question and required adequate working to be shown to get that mark. Now, based on how the calculator presented answers for me in this question, we didn't actually need to use what the examiner references next, but the examiner says that students are expected to be familiar with the identity sine squared of x plus cos squared of x equals 1, as well as equivalent forms such as sine squared of x equals 1 minus cos squared of x. And the reason for that is if you have a look at the first line up here of the examiner's report, one of the ways that the height of the pyramid could be expressed was the square root of 100 sine squared of x minus 100 cos squared of x. So that actually required the substitution of that sine squared of x in here with 1 minus cos squared of x to progress on to the answer. So that's why you need to be familiar with identities such as that and the rearrangements as well, so that depending on how the question goes and what calculator outputs you get, you can still progress through questions like this using those identities. Next up, the question says that Queen Hepzibah's pyramid was designed so that it had a maximum possible volume. So for part E, it asks us then to find dt dx, and then hence to find the exact volume of Queen Hepzibah's pyramid and the corresponding value of x that maximizes that volume. So the first part of this question is just to find dt dx, and we can use a calculator to do that. So now on the calculator, I'm just going to type out the rule for t. So it was a fraction, and it was 4,000 divided by 3, and then that was multiplied by the square root of, and then we had for the calculator, it will need to be a bracket, cos of x to the power of 4. and then we had minus 2, and then in a bracket cos of x to the power of 6. So just make sure you've got that entered into your calculator correctly. So when we have cos to the power of 4 of x, that's the same as cos of x to the power of 4 in a set of brackets. So now we can highlight that input and we can define it. So interactive define, and the function name, I am going to replace the f using ABC, and I'm going to put capital T in there because that's what the exam gives, is t of x. And hitting OK, we've now defined that rule. So t of x, we can now drag that down and differentiate it. So I'm going to highlight t of x and go interactive calculation diff, and hitting OK will calculate the derivative. And now that's quite a lengthy thing to write out in an exam. So sometimes it's worth just hitting the simplify button, which is up the top of the screen, and that will give us a slightly nicer format for the derivative of t. So we're going to write down the simplified version of that derivative which the calculator gave us. So that was that we had 3000 sine of 4x plus 2000 sine of 2x. And that was all divided by 3 square root of negative cos of 2x. So that's one simplified version of dt dx. And you'll see on the next slide, the examiner's report quotes a different one, but there's going to be many acceptable forms of this derivative. So even if your calculator didn't show exactly the same thing, hopefully when we go to solve this equal to 0, you'll still get the same values of x. So next we want to solve dt dx equal to 0. And the reason why we want to do that is that we want to maximize the volume of this pyramid. So dt dx equals 0, you can solve it on the calculator, but one thing I'll just point out is that when you're solving a fraction equal to 0, it's actually possible to just solve the top line equal to 0. So another way we could solve this would be 3000 sine of 4x plus 2000 sine of 2x is equal to 0. So that's just something that you can keep in mind in case your calculator has any difficulties. You can just solve the top line equal to 0 if a fraction is equal to 0. So back on the CAS calculator, we now want to solve this equation equal to 0. So I've just dragged it down to the next line, and I'll put equals 0 next to it. And because it's a trig equation, what we'll want to do is restrict the domain so that the calculator only looks for solutions over a particular domain that's given in this question. So using Math 3, we can put the straight up and down line next to the equation, and we can specify that we want to go from pi on 4, so this is all the way back at the start of the question, and x is going to be greater than that but less than pi on 2. So we can set all of that up, and now when we highlight including the restriction and the equation, once that's all highlighted, we can go interactive equation inequality solve for x, and it will find the solution, the value of x that's in that domain, that makes the derivative equal to 0, which will find a maximum stationary point for us. So solving on the CAS calculator with the suitable restriction that we needed, we found that the x value is equal to, and it's 2 tan inverse, and then in brackets we had root 6 minus root 2, all divided by 2. So that's part of the answer to this question. That's the value of x that does maximize the pyramid's volume. And the next thing we need to do is actually find the volume. So that's going to involve taking t and substituting 2 tan inverse of root 6 minus root 2, all divided by 2, into that rule. So next we want to evaluate the function t when x is equal to that value. So going into ABC, we can go capital T, and then in brackets, we can put the x value we want substituted in there, and we can hit execute. And once again, that's a lot of writing to put down. So we might want to just check if we can simplify that by hitting the simplify button, and we actually get quite a convenient answer of 4000 root 3 on 27. And using the simplified answer that the calculator gave, this is equal to 4000 root 3 all divided by 27. And the units given in this question are in meters cubed, so we can do meters cubed there as part of our answer. So that is the other part that's required for this question, the value of x and the maximum volume both in exact form. From the examiner's report, we can see that 17% of students got this question fully correct, and that several approaches were possible to find the zeros of the derivative, or when the derivative equals 0. Some students did obtain the derivative by hand and then noted that it would be equal when 3 cos squared of x minus 1 equals 0, which wouldn't have been apparent in the format that we gave it in. But again, the examiner's report, if you look up above, does give a version of the derivative where you can see the null factor law gives 3 cos squared of x minus 1 equals 0, a sufficient equation to solve for this question. Others used technology, and some used a combination of by hand working and technology to get the derivative. Some of the outputs from the technology were long, but correct and acceptable expressions. And again, using simplify on your calculator allowed you to get an easier expression to write down. The examiner goes on to say that some students did not restrict the domain and gave a general solution for x rather than the specific value of x that was required for the question. The examiner also suggests that students could graph the function to check that their solution with respect to the domain of pi on 4 to pi on 2 was the correct answer that you needed. And the last thing that the examiner says is that exact answers were required for x and t. And it was actually asked for the exact value in the question, but you should know that exact values are the default that you need for a VCAA exam like this. So question 3 goes on to say that Queen Hepzibah's daughter, Queen Zepzibah, was also buried in a pyramid. It also had WA equaling WB equals WC equals WD equals 10, which means we have the same volume formula applying to this question. However, the volume of Zepzibah's pyramid is exactly 1/2 of the volume of Queen Zepzibah's pyramid. The volume of Queen Zepzibah's pyramid is also given by the formula T, which I've included up above. For part F, it says find the possible values of x for Zepzibah's pyramid correct to 2 decimal places. So unpacking what this question introduces and tells us, we want T of x, so the same rule applies for Zepzibah's tomb, to equal 1/2 of the volume of Queen Zepzibah's pyramid, which was the maximized volume, which was the 4,000 root 3 on 27 that we just found earlier. So we want to solve T of x equals 1/2 times that fraction. So now that we've got an equation to solve, we can use the CAS calculator to do that efficiently. So I'm going to go ABC, and then I'm going to go capital T, and then it's just of x this time is equal to, and we want it to be 1/2 the previous volume that we just found, so 1/2 times this fraction. And once again, we'll want to restrict this so that we get the t value that we're after. So under math 3, we can do given that, and we can put pi on 4, and then that's going to be less than x, which is going to be less than the fraction pi on 2. And then we can highlight that and go interactive, equation equality, solve for x. And from the calculator, we can see that the decimal answers, correct to 2 decimal place, were going to be x equals 0.81 and x equals 1.23. And the question does ask for the possible values, and these two are between pi on 4 and pi on 2 because we restricted the calculator so that they'd give us any answers that are between those two values. So we needed to quote both of these to get full marks for this question. So that's the answer to part F. From the examiner's report, we can see that only 12% of students got full marks for this question, so it became a really challenging question for students to complete on the exam. The examiner goes on to note that this question could have been answered independently of 3E, using a numerical or graphical approach to find the maximum value and then solving for half of that, which would have been 128.300 as shown above. So even if you had failed to get the exact values that were required in E, a graphical approach still would have allowed you to complete part F of this question. Some students did not give their answers correct to 2 decimal places, or they only gave one answer, which means they would have missed marks for this question. Some students incorrectly solved this equation, which actually halved the T of x side of the equation, rather than halving the volume of Hepzibah's tomb, which was required.